All right, so we're going to be talking about sequences, and we're starting out specifically talking about arithmetic sequences. Arithmetic sequences are a linear pattern that is made by adding the same number each time. Now, in order to find that same number, we're going to do what's called finding the common difference. So our D is our common difference, okay? And the N, let's write difference. And the N represents the term number, okay? I'm going to pause, let you write copy. Now we're going to go down to geometric sequences. Geometric sequences are an exponential pattern made by multiplying the same number each time. Now, term 1, T1, this T1 is term 1. That is the first term in the sequence. The R represents the ratio. That's the ratio between the terms. Okay. All right, we're going to go to our first example. And we don't know if this, well, it says common difference. The first one, so T1, the first term is 2. Think about these as coordinate points. So in other words, if x, so think about that term 1. If x is equal to 1, this 2 is our y value. This, if x is 2, our y value is 9. If x is 3, y value is 16. So term 3 is 16. Term 4 is 23. Okay. Now, in order to find the common difference, you're going to look at the second term, so term 2, which is 9, and we're going to subtract the first term from that. 9 take away 2 is going to give us 7. So if I look at 9 and add 7 to 9, that's going to give me 16. If I add 7 to 16, that's going to give me 23. So now we're going to generate the next 3 terms. So 23 plus 7, well, let's do 23 plus 7 is going to give us 30. This is going to give us 37. This is going to give us 42 for the next term. Okay. Each number is more than the term before, starting with the number 2. Each number is 7 more than the term before it, starting with number 2. That's how we're filling out that sentence. Okay, I'm going to pause. I would like you to try to do number, oh, wait, now take that back. Yeah, try to do number 2. This D is the same thing as the common difference. Notice this D is underlined. That's showing you that it's asking for the same thing. So pause the video here and see if you can do it. I'm going to go ahead and go forward. So term 1 is 95. I'm going to do 89 minus 95. I'm going to do the second term. You want to make sure you do the second term so that you realize here each term is minus 6, or rather you can say 6 less, so that's minus 6, than the term before it, starting with term number 95. We're going to generate the next 3 terms. So 77 take away 6 is going to give me 71. 71 take away 6 is going to give me 65. 65 take away 6 is going to give me 59. So notice our numbers are getting smaller. All right, number 3, we're generating a similar pattern. So each one, our term number, so here's representing it as the values. So think the sequence would be negative 20, negative 15, negative 10, -5, so on and so on. But it's representing to you as a table. You can still do the same relationship because this is a sequence. I can tell it's a sequence for a couple of things. I know that I have a common difference. If you take -15 minus, be careful, -20, minus and a minus become a plus. So 20 take away 15 is going to give me minus or positive 5. Really take that back. Hold on. We are subtracting to get, yeah, we are subtracting 5. Should be, yeah, we're just going to take 15 minus 20. I should have been -15. That's where I messed up. Okay. -15. So the 15 minus 20 is going to give us minus 5 because we're going down. Our first term is 1. So each term is 5 less than the term previous, starting with number -20. So this is going to be 0. Oh, hold on. I take that back. I was correct. Oh, hold on. Got to make sure I'm backing up. Because I did do the math correctly. So notice our numbers. If I add 5, because think, I have -10 here. So that means the next term here is going to be added 5. So the common difference should be +5. So it was -15 minus 20, which gives me 20. So each term number is 5 more than the term previously, starting with the number -20. So I caught myself. So then term number 6 is going to be 5. Term number 7 is going to be +10. So our sequence number would be 5, 10, going on and on. All right, those are arithmetic sequences. All right, now we're going to look at some geometric sequences. Geometric sequences, you notice if you do 6, take away 2, that would give you 3. But if you add 3 to 6, that's not going to give you 18. So we know that we have a multiplier here. We don't have a common difference. So I'm going to do 6 and divide that by 2. So you want to take the second term, because this is term 1, this is term 2. I'm going to take the second term, which is 6, and divide that by the first term. That's going to give me 3. So I know our ratio is 3. So I'm taking 6 times 3, that gives us 18. I'm going to do 18 times 3, that's going to give us 54. Now I'm going to do 54 times 3. That's going to give me 162. 162 times 3. It's going to give me 486. I'm going to do 486 times 3. Oops. Gives me 1,500 or 1,458. All right, our term number here, notice we're getting smaller. Now, with exponential functions, because all of these geometric is exponential with the ratio, when we're going down our exponent, we're going to have a fraction, we're decreasing, so our b value, our base, which is our ratio, is going to be less than 1. On number 1, our b value was greater than 1. Think about how an exponent would be set up. So this would be 2 to the x power. Now there's some more to it than that. That would be actually 3 to the n minus 1 power. We'll talk about that when we look at the actual formulas tomorrow. Right now we're just looking at recognizing the patterns and finding that ratio. So I'm going to take the second value, 1024, and we're going to divide that by our first value, which is 2048. That gives me 0.5. So our ratio is 0.05 or 1/2. All right, now we're going to do the next 3 terms. So I'm going to take 256 times that by 1/2. That's going to give me 128. I'm going to take 128 and times that by a half. That gives me 64. I'm going to take 64 and times that by a half. That gives me 32. I'm going to pause, let you copy. All right, number 3. We still have a geometric sequence. Mostly I'm also identifying that it is a geometric sequence because that R value there, that's letting me know we have a ratio. So again, I'm going to take negative 12, divide that by our first term, and that's going to give me negative 2. Okay, and our term 1 is 6. So this is basically x, and this is y. So this is our term 1, this is term 2, term 3, so on and so on and so on. Okay, so I'm going to take negative 48. Also notice, because we have a negative number, be careful. Negative and a negative are going to become a positive. So do watch your signs on these. So negative 48 times negative 2 is going to give you positive 96. So our numbers here are getting bigger because our base value is greater than 1. I'm going to do 196. So think our next one is going to be negative, and then this next one, the number 7, seventh term is going to be positive, because this one's positive because a negative times a negative is going to give you a positive because our ratio is negative. So 96 it's going to give me negative 192. I'm going to times that by 384. All right, on this one, we're writing our sequence. It tells me the first term in the sequence is 5, so I'm going to put 5 for the first term in our sequence. And then we know that the common ratio is 2, so it's a common ratio. That means multiplier. So 5 times 2 is going to give me 10. 10 times 2 is going to give me 20. And 20 times 2 is going to give me 40. And that pretty much concludes the gist of the lesson. And you have a half sheet. On the next video, I'm going to do a couple of the questions on that little half sheet and then leave you to the rest to do the rest on your own.